Hello everyone, welcome to your mathematics class. Today we are going to solve exercise 1.3 so that you can easily check your answers. So let's get started with the exercise. Question 1 of this exercise says, write the following in decimal forms and say what kind of decimal expansion each has. So the first question is 36 upon 100. So we are going to divide 36 by 100. We get the answer 0.36. How come this answer came out? We first put a decimal over here. After that, 0 keeps on coming on it. Remember the rule of division? So 360 will 100 threes is what? 300. So 360 minus 300, we will get 60. So another, after the decimal, 0 keeps on coming in. So 0 gets over here. And 106 is what? 600. So we get 0 as remainder. So what kind of expression is this? Expansion is this? It's a terminating expansion. So it's a rational number. Now part 2 of this question says 1 divided by 11. So when we divide 1 by 11, it's not possible. So we put a decimal and after that 10 will be coming. But 10 can't be divided by 11. So we put another 0 and then we got 100. 11 nines are 99. So we got the digit 1 again. Again, if you see, the remainder is keep on repeating. Again, we will put a 0. Then we got the digit 100. Then 99, 11 nines are 99. We get 1. So this is what? Non-terminating, because 1 is keep on coming. So it's a non-terminating, as well as it's repeating itself. Look, 1 is repeating itself. So it's a non-terminating as well as repeating. You know, non-terminating and repeating is what? A rational number. Next, let's move to the third part of this question. It says 4 1 by 8. So it's an improper fraction. We will turn it into a proper fraction. That will result into 33 by 8. How come this figure came out? 4 into 8, 32. 32 plus 1, 33. So 33 upon 8. Then in the same way, we divide 33 by 8. So 8 fours are 32. Then it's 1. So 1 can't be divided by 8. So we put a decimal. After that, 0 keeps on coming. Only once at a time. So 10, 8 ones are 8. Then we got 2. Then again 0 will come out. Then 8 twos are 16. Then we got 4. Then it will become 40. Then 8 fives are 40. So it's a terminating rational number. Like this, you will solve the rest 3 questions. I hope you all can solve it. 3 divided by 13. I will take a little faster. So when we divide 3 by 13, we will get this as a question. 230769. After the 9, again you will see that 3 came out. So 3 is what? Over here. So again the same string will follow. So that's why I have put it that bar. And this is what? Non-terminating repeating rational number. Now the fifth part says 2 divided by 11. Then it's what? 2. We put a decimal. Then we got 20. 20 can be divided by 11. So 1s are, we get 90. 11 8s are 88. Then we again get 2. So it's a repeating one as well as non-terminating. So we got non-terminating repeating rational number. Now if we look over here, this question 329 by 400. So we put a decimal, then 8s are, then we got 90, 90, then again 0 will come out, then 400 2s are 800, then again we will get 100, then again 0 will come out, then 400 2s are 800, then again we get 20, and then it will cut it off. So the remainder will become 0. So it's a terminating rational number. This is how we solve question number 1. Let's move towards the question number 2. It says, you know that 1 by 7 is equals to 0.142857 bar. That means it's keep on repeating. After 7, again we will get 142857. So the question says, can you predict that the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 are without doing actually the long division? If so, then how? As you all know that 1 by 7 is given, the value of 1 by 7 is given over here. So 2 by 7 is what? 2 into 1 by 7. So we can write it 2 into this. As we have got that value of 1 by 7, then we multiply it and we get this answer. In the same way, we multiply 3 with the value of 1 by 7, we will get this answer. Then 4 with 1 by 7, then we will get this answer. In the same way, 5 into 1 by 7, we will get this. 6 into 1 by 7, we will get this. So these are non-terminating repeating decimals. As if one answer is non-terminating repeating, as we know the value of 1 by 7 is 1 non-terminating repeating. That's why all the multiples of it will be non-terminating as well as repeating. Now let's move towards the third question. Express the following in the form P upon Q, where P and Q are integers and Q does not equal to 0. That means it's a rational number. Express them into a rational number. I told you the method of making a decimal expansion into a rational number. So this is how this question will going to conduct. Now let's move towards the first part of it. It says under root 6. Oh, sorry. It says 0.6 bar. 0.6 bar, we have to convert it into a rational number into a P upon Q form. So let's take 0.6 is equals to 0.6 bar is equals to x. Then we have to multiply on both the sides by 10. So 10x is equals to what? As this will be equal to what? 0.666 and goes on. So when we multiply 10 on both the sides, that is on the left hand side and the right hand side, we will get what? 0.666 into 10 is what? 6 into 666. So 6 can be written as 6 plus 0.66. 0.66 is what? The value of x. So we can write it 10x is equals to 6 plus x. Then we will get 10x minus x, like terms will be put on together, is equals to what? 6. Then 9x is equals to 6. X is equals to 2 by 3. We have solved this question but in our video also. Now 0.47. The next question says 0.47. Let's take x is equals to what? Over here you can see that only 7, the string is only on 7. So 7 is keep on repeating, not the 4. So we have to follow that string. We have to make decimal. After the decimal, the string have to follow. But here we are having 0.47. So if we have to take it out, so what we should do? We should multiply it by 10 because we are only having one number. So we are going to multiply it by 10. So 10x is equals to 4.7 bar. Bar means it's keep on coming 777. Now what we are going to do? we are going to follow the same pattern which we have followed in our previous question. So we are going to multiply 10 on both the sides because string is of one element. So we are going to multiply by 10 only. So 10x will be multiplied by 10 and 4.7 bar will be multiplied by 10. So 100x is equals to 47.7 bar. 7 bar 4.7 bar is equals to 10x. So what should be minus from this so that we can get the value of 4.7? 47.7 bar से अगर हम इतना माइनस करेंगे we will get 43 and we will 47.7 bar can be written as 43 plus 4.7 bar. So 100x is equals to this. Now 100x will be equal to 43 plus 10x. 4.7 bar is what? 10x. So we have put it 10x over here. Then we will put like terms together. 100x minus 10x is equals to 43. Therefore 90x is equals to 43. Therefore x is equals to 43 by 90. Understood? Now we will move towards the third part of it. It says 0.001 bar. So let's take x is equals to 0.001 bar. So we are going to multiply, as the string consists of how many digits? 3 digits. So we are going to multiply it by 1000. So 1000x is equals to 1.00 bar, because 00 will be of no number. We are not going to pronounce it. So 1000x is equals to 1.00 bar. So 1000x will be equal to 1 plus 0.00 bar. We can write it like that. This value is what? X. So 1000x is equals to 1 plus x. Therefore 1000x minus x is equals to 1. Therefore 999x is equals to 1. Therefore x is equals to 1 by 999. Let's move towards the fourth question. Express 0.9999 infinity in the form of P upon Q. Are you surprised by your answer? With your teacher and classmate, discuss why the answer make the sense. Let's take x is equals to 0.9, as 9 is repeating, so it's only of one number. So we are going to multiply it by 10. Therefore 10x is equals to 9.9 bar. Therefore 10x is equals to 9 plus 9 bar. Therefore 10x is equals to 9 plus x, as 0.9 bar is equals to x. So we have put that value. Then we get 10x minus x is equals to 9. Then we get 9x is equals to 9. Therefore x is equals to what? 9 upon 9 is equals to 1. How could this be possible? Because 1 can't be equal to this. But 1.999 is the approximate value of 1, can be written as the approximate value of 0.999. Yes, we are surprised because 0.99 can never be equal to 1, but can be approximately equal to 1. So this will be our answer. Now let's move towards the question number 5. It says, what can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 upon 70? Perform the division to check your answer. As I have already told you that number of repeating digits will be always less than 17. How come? Because n minus 1 would be 16. So the number of repeating digits will be how much? 16. Remember? So when we divide this whole expansion and 1 divided by 17, when we keep on dividing it, we will get this value 0.001 0588235294117647. And if you count them, how many digits is this? 16. Now, if you see at the remainder, after this whole multiplication division, you will see the remainder came out 1. 1 is what? The actual figure from where we have started. So, the string is consists of 16 elements, 16 numbers, and it's keep on repeating. Thus, in this way, we have solved this question. Hope you can do this in your own by yourself, and you will get the string of 16 digits. Now let's move towards the sixth part of this exercise. Look at several examples of q in the form of p upon q, where q does not equal to 0, where p and q are integers with number common factors other than 1. Having terminating decimal representation, can you guess what property q must satisfy? Are you able to get this question? The question says you have to take some examples where you must be getting common factors other than 1 having a terminating decimal representation. So let's move towards the question solution. Let's take some example. I have randomly taken some example. 3 by 8, half, 2 by 10, 35 by 10. So this in the lowest term can be 3 by 8 is the lowest term, then it will be same. Half same. 25 by 10 can be represented as 5 by 2, and 35 by 10 can be written as 7 by 2. So in each case you have noticed that something in Q, all these are what? Are the multiples of 2. Now let's divide each one of them. Means 3 divided by 8, 1 divided by 2, 5 divided by 2, and 7 divided by 2. So in each case we are getting no remainder. If you see over here, the remainder is 0 in each case. So these are what? Terminating numbers. So what will be the property of this question? If you see that 2 is the common factor in the denominator. So here we notice that in each case q is a multiple of 2. You all this confusion and all these things will be clear when you will be in class 10th by getting the proofs of decimal expansions. So here we can say that prime factorization of q in the form of 2n and 5m, where m and m are the whole numbers. Means if in the denominator you get a multiple of 2 or 10, you will get it as a terminating number. Here even the q are in the form of 2 upon n or 5 upon m. Suppose if 2 raised to the power m and 5 raised to the power 0, as in the same case where we have written over here. Okay? Then what will the form of this? 2 raised to the power 3 and 5 raised to the power 0. 5 raised to the power 0 means 1. So we are satisfying this form. So here the number will be terminated. Now let's move towards the question part 7. It says write 3 numbers whose decimal expansions are non-terminating and non-recurring. So it's up to you. You can write it as you wish. I have written any 3 numbers which are non-terminating and non-repeating. So these were my wish of answers. Now let's move question number 8. Find three different irrational numbers between the rational number 5 upon 7 and 9 upon 11. So, when we divide 5 upon 7, we will get this string. And when we divide 9 by 11, we will get 0.81 as this string. So, we are going to write down any number in between these two strings. So, those will be our answers. I have taken any number. It's up to your wish. You can take any number. So, the answer will differ in from everyone. Okay, so let's move towards the last question of this exercise. Classify the following numbers as rational or irrational numbers. Under root 23. Under root 23. As you all know that under root 16 is a perfect square and under root 25 is also a perfect square of 5. So, under root 23 will be an irrational number as 23 is not a perfect square. Question number part 2 of this question, under root 2 to 5, 225. 225 is a square of what? 15. So it's also a rational number. Now 0.3796. 3796 is a terminating number, so it will be a rational number. Fourth part says 7.478478 and goes on. So it is what? If you see the string, it's repeating 478, then 478. So this is what? Non-terminating repeating. Non-terminating repeating is what? A rational number. Then 1.1001000100001 and goes on. So this is what? Non-terminating and non-repeating, as if you see it's not repeating. So it's what? An irrational number. This is how we have solved the whole exercise of 1.3. Hope you have understood it well. Thank you all. We will meet again soon with our next video. Till then, stay safe, stay at home.